Okay, this is video number 4. The first 3 videos covered all material for test 3. This video is just hand-picking some problems from the handouts that you might be struggling with. I did not put notes online for this video since I already have answer keys for all of the handouts in module test 3. This is what we're about to do. Do not watch this video until you have already practiced all of the problems yourself numerous times. Watching me at this point is not going to be that helpful until you've already struggled with the material yourself. But anyway, assuming you've done that, have handout 9, 11, and 12 out. Have the review day handout. Have the cheat sheet, the Z-chart, the CI chart. There is a chance I will make one more video in 2 weeks if I get a lot of questions from students that are asking for particular problems and I feel like I can't answer that through the discussion board or email. So we're going to play that by ear. There will be one more video that helps make up for these missed on-campus days, and it's going to be an introduction to test 4. Basically, you can watch it whenever, but I really would recommend watching it the night after you take test 3, meaning before you come back into lecture, because that way it's not going to confuse you between test 3 and test 4 material. All right, let's get started on a few of these problems that I tend to be asked about. Got to find my eraser. Okay. Just to recap a few more things, remember this is the cheat sheet. What I have circled is the only thing you need for test 3. There are the 2 different confidence interval formulas. But remember, you have to memorize where to go on your calculator. This is the information for sampling distributions. XX bar is the same camp. They're going to be giving you the mean and standard deviation. How are you going to know that it's an X bar problem as opposed to an X problem? The X bar problems are going to give you a sample size. But also, and as important, it's going to ask you a question about the mean. Because, of course, these problems give you sample size also. So just locating a sample size doesn't tell you anything. But proportion problems are going to talk in fractions or in percents. Confidence intervals, you won't be able to miss that it's the topic called confidence interval because I have to ask you for the confidence interval. So those are usually pretty obvious. Remember, on your calculator, you're going to T interval. And on your calculator here, you're going to 1 prop Z int. Everything I've said is really review of the last 3 videos. Remember, the CI chart is just to show the setup of the confidence intervals. Most of this chart, all of this stuff, is for the confidence intervals for mu, which require a T value, which is based on degrees of freedom. The bottom row is where you'll get your Z critical values for the proportion confidence interval, just for the setup. All right, we're going to start with handout 12, number 2. Handout 12, number 2 is not hard. Handout 12, number 2. Candidate Andrew, favored by 53% of 1,000 voters. Based on a 95% confidence interval, can we conclude, will Andrew win? All right, so we have to set up our confidence interval. Again, they asked people, are you going to vote for Andrew? They would have said yes or no, so this is definitely a proportion confidence interval, because it says confidence interval. So here's our formula, right? P hat. When they tell it to you in percent, this is very easy to show the setup. All you have to do is put that in decimal form. Thousand, yes. You go to the bottom, because this is a Z value of your confidence interval chart. This asks for 95%. There is that famous 1.96. Okay. Now we're going to 1 prop Z int on your TI-83. Stat test 1 prop Z int. Enter. Remember, here's the issue. It does not ask you for P hat. You have to actually figure out how many people are going to vote for Andrew. So you have to figure out what 53% of 1,000 is. You can do it right there. 0.53 times 1,000. I've mistyped. N is 1,000. Sea level's 95. Calculate. So somewhere between 49.91% and 56.09% will vote for Andrew. This problem specifically said there's only 2 candidates running. So in order for Andrew to win, he would need over 50% of the vote, over 0.5. See how that's a little bit below 0.5? I made this one really, really close to make sure that you understand that for confidence intervals, the entire thing has to do whatever they're asking. This entire thing is not greater than 0.5. So will Andrew win? No. There's not evidence since the entire CI is not greater than 0.5, or you could say no, since the CI goes down to 0.4991. You have a little bit of freedom there. All right, I'm going to erase. We'll go on to the next problem. Set up, confidence interval, answer. That's what makes a complete problem. Number 5 now. This one was designed to make sure you knew how to use your calculator. When you guys watch me on videos, you're not testing yourself. And then you go to take my test and you mess it up because you've never practiced. So if you have not done handout 12 number 5, do it right now before you ever watch this. This is about loving cats. Okay, 26% of 525 males. 33% of 405 females. And they're asking, is there a difference in the proportion who love cats? And if you're looking at handout 12, I'm just trying to prompt you to make a complete explanation. So we are doing a 99% confidence interval. All right. So again, since they gave it to me in percent form, sorry, I was checking my video. Since they give it to you in percent form, this is real easy to set up. 99% Z is 2.58. I'm going to set up my males and then my females. Oops. Okay, going to one prop Z int. You're going to have to do exactly what we did last time, except I have a feeling this is going to turn out to be a decimal. This is where you might get a dimension error. So let's do it one more time together. Go to your one prop Z int dx 0.26 times 525. When you hit calculate, you have a decimal. If you hit calculate now, you will get a dimension error. 136.5, just round that properly. That's going to round to 137. So I'm going back up to make that a 137. The N is 525. Sea level's 99. Calculate. Pause the video, do your females, come back, check your work. Okay. And what were they asking? Is there a difference? If there is, who has a higher proportion? If there's not, how do you know? These two confidence intervals overlap. If that confuses you because they're so far away, and a lot of times when things are horizontal, it gets confusing, you could kind of just move this one over just to approximately, if you had a number line, and see how they overlap in all of those numbers in there. So you can't tell since the confidence intervals overlap. Very similar to last problem we just did. There is a part B. Is there evidence that greater than a quarter of the men? So this is a men. This is the men's confidence interval. And they're asking you if that is greater than a quarter. A quarter is 0.25. So the answer is no, since the entire confidence interval is not greater than 0.25, or you could say no, since the confidence interval goes down to 0.2116. Honestly, on handout 11, number 6, I think I'm just going to make a comment because that one is not any harder than this one. It's handout 11, number 4, that's the trickiest one. So handout 11, number 6, is talking about women guessing the sex of their unborn baby. Then it says test that women guess better than chance level? I usually get a lot of questions from students on that. Think about it. Stereotypically, traditionally, there are two genders, male and female. It's kind of like flipping a coin. Chance level, when it comes to guessing the sex of an unborn baby, they're referring to 0.5. So you have to do your confidence interval and then see if the entire thing is greater than 0.5. So that's usually the question I get on that one. Let me put a few of my handouts away. Okay, so what I really want to do with you right now is handout 11, number 4. So take a look at that one. This is the only one on all the handouts that do not ask you, is it greater than a number or less than a number? All of our interpretations have been about the entire, here's my hands, I wish I could be in front of you, the entire confidence interval being greater than whatever they asked or being less than whatever they asked. This one is very different. This one is actually foreshadowing some test 4 material. That is why it's on here. So this, let's see. I immediately can tell it's a mean confidence interval because they've given me mean and standard deviation. Test whether the pulse rates are 72. Do it for men and women. Do the confidence intervals. Let's get the confidence intervals first, then we will talk about the weird wording. So this is back to confidence interval for mu. X bar plus or minus, I'll come back to the T. S over square root of 35. My men, X bar plus or minus, I'll come back to the T. S over square root of N. I'm going to get my CI chart. Degrees of freedom here is 34. Of course, 34 is not listed. What level do they want? 95%. All right, so 95%. I can't find 34. If you just want to go with 30, that is perfectly fine. This one, degrees of freedom, is 36. Again, I cannot find it. I guess 36 is closer to 40. You want to go with 2.02. We just have to use our skimpy chart. Just go with the closest thing you can find. Now remember, we're going to T interval on your TI-83 now. T interval. We do not have data. I did not put data in L1. I actually have the statistics, the X bar and the S. So I'm selecting stats. Let's do the females together. X bar is 76.9. S is 11.6. N is 35. C level is 95. Hit calculate. It always takes a minute. Pause the video, go do your men, come back, make sure you have it right. Okay, so those are the 95% confidence intervals for all Penn State females, and then for all Penn State males, not just the 35 and the 37, but for the population. And it says basically for each one, test whether the pulse rates are 72. So it's kind of, these are what I call the could it be problems. It didn't say greater than 72. It did not say less than 72. It basically said, could it be 72? So on the could it be's, you were actually just looking to see if that number is contained in the confidence interval. So this one, no, 72 is not inside the confidence interval. This one is a yes. Yes, it could be 72, since 72 is within the confidence interval. Okay, so on the ones that it just says test whether it's 72 or not, basically they're asking, could it be 72? Yes, I'm sorry, pointing to the wrong one. No, it cannot be 72 since 72 is not contained in there. See, 72 would fall right here. This one, yes, since 72 is in there somewhere. Again, this really is foreshadowing something called a two-sided hypothesis test on test 4. That's why we're covering this now. All right, so that's all I want to do for confidence intervals. They're really not that hard. Maybe another review comment I want to make, and I made it somewhere on video 2. So this was a mu problem, right? This was x bar plus or minus t s over square root of n. Make sure you understand that the x bar is directly in the middle of that confidence interval, right? Because we're going x bar plus or minus. You're at x bar and you're adding and subtracting the same amount. So by its very nature, if you found the midpoint of this interval, if you found the average of those two numbers, of course it is x bar. That's how we build it. So when we say that we're 95% confident of the true pulse rate for Penn State men, we don't know where in there it is. It's anywhere between 67.1 and 73.7. There's nothing special about the middle because actually the middle is the x bar, and we've already discussed many times how we have no idea how sure we are about that one sample. We're 95% confident about the confidence interval. All right, now I want to move on to sampling distribution. That's the stuff you don't like on test 3. Let's go back to handout 12, number 1. Handout 12, number 1. So I'm going to put my CI chart away. Definitely have my Z chart out. I'm getting organized here. I'm going to put my handout 11 away. Okay. Virginia SOL test scores are skewed. I want to pause right there. When I read that, I know for a fact they are not going to be able to ask me an X problem because it's skewed. I cannot use my Z chart unless something is normally distributed. So I certainly hope when I keep reading this problem that they end up giving me a sample size and asking me a question about the mean. I will see. There we go. There's that sample size I was completely expecting. Can we assume normality? Yes. This is how you have to show it to me. 36 is greater than or equal to 30. I will not give you credit if you just do that because I have too many students who do not know what n is. So you have to show it like that. What is the probability their mean is great? See, they gave me the sample size, and then they asked a question about the mean, their mean. That is the second clue that you cannot miss to know this is an X bar problem. So they are asking X bar greater than 85. Okay, I already know it's normal. Let me get my scratch work. The mean is the same thing. Remember, it's all about the standard deviation. It's no longer 2, it's 2 divided by the square root of 36, which is 0.3333. Keep at least 4 decimal places. Obviously, it's repeating. I'm going to turn the X bar into a Z. How do I get Z's? I subtract off the mean. I divide by standard deviation. Here is one that is off the chart. Some of you struggled with this on test 2. Intuitively, if you're way up here at 9 and I'm asking greater than, there's nothing left. I already know intuitively that the answer is 0%. If you don't like the intuition, you can look up, let me get a different color pen. You can look up, since this is positive, 3.89 on your Z chart. That's the biggest Z you can look up. When you look up 3.89, you're going to see 1, but this is a greater than problem, so I'd have to go 1 minus 1, which is 0%. Whichever way, intuition or using the Z chart, the answer is 0%. Let me get room for part C. Part C. Okay, let me erase the whole board. Lots of you did not do this correctly on test 2. There is the word at least again. First of all, I have to use the proper wording. I'm asking you a question about the mean. So it's still an X bar problem. But I've given you the area. So this is a working backwards X bar problem. Since it's a working backwards, the picture is critical. 16% at least. That means you're coming in this way 16%. There is your picture. 16% greater than. The problem is your Z chart does not want to know who lives on the right. It wants to know who lives on the left. In order to talk to your Z chart, you're going to have to talk about an area of 0.84. This is an area, not a Z-score. This is where you're searching the body of the chart for 0.84 or as close to that as you can get. What you'll actually find is 0.8389, but remember that's the area. That does not equal X bar minus mu over sigma. You have to get the Z-score. The Z-score for that area is 0.99. Equals, I don't know what X bar is, but I know the mean and I know the standard deviation. Make sure you're picking up the 0.3333 and not the original 2. Do have some algebra. There's your answer. We're going to move on to handout 9. This was one of the trickier ones. When I did, I don't remember, video number 1, I even made reference that the problem I did in video number 1 would help you with this problem. So hopefully you've practiced this a couple times. This one does not even have a word problem context. It's very just straightforward. It tells you the population proportion is 0.7. But then it has that language in part A of what's the smallest n to basically make p hat normal. So remember your normality criteria for the proportion sampling distributions. You're going to put in your p. You're then going to divide by the 0.7, divide by the 0.3 to get your 2 answers. And then remember that the rule is pick the largest and round up if it's any decimal. That is not a decimal, so our answer is 50. I am drinking coffee for a second. Read part B. Yes, these are the ones that talk about being within, so it's making a stuck in between problem. So it does say sample of 50, so I already know I'm okay on normality, so I don't have to recheck it. It's asking a question about the sample proportion. Remember all of these problems? They give you n, they give you p, and they ask you a question about p hat. This is within 0.25 of the population proportion. We know what the population proportion is, 0.7. They want us to be within 0.25. So really, this is what they're asking. 0.7 minus 0.25. At some point, we're going to have to solve what that is. But we're not quite ready to solve it yet because we've got some scratch work we need to do. P hat is normal. I already know that. The mean is the p. The standard deviation is that yucky term. That's the standard deviation. I'm going to cheat and find out what that number is, 0.0648. So now I'm ready to solve this. I think I'm going to come up higher. So we are trying to solve this right now. I have to get 2 z-scores. How do I get a z-score? I subtract off the mean, divide by standard deviation. See, the mean and standard deviation of p hat, you have to calculate. It's not given in any form in the problem. You have to do all the calculations. Work that out. You should always come up with the same z-scores on the stuck in between where it says within. Just one negative, one positive. Remember, you'll go look this guy up, minus you'll go look that guy up. I was sitting here thinking, handout 9, number 3, again, is not that hard. I think review day number 3 and 4 do a lot more, so we're going to go straight to the review day handout. So make sure you get that out. I'm going to erase, so pause it if you're not ready. So this review day, I just made up some problems and threw them on a piece of paper. We're going to do number 3. Let's see. "43% of students like cats." So I kind of am skimming. This is obviously not confidence intervals. So immediately I know this is a proportion problem. They did not ask me or tell me on average how many cats people had. They just basically asked people, do you like cats or not? Part A. I will ask the next 100 people. See, they gave you P, they give you N, and they're going to ask a question about P hat. What is the probability I find more than 90%? That's the question that they're asking you. So we got to check for normality. Well, yes, that's 43. Of course, the other one, yes, that's 57. We're fine for normality. So I do know P hat's normal. The mean of P hat is P. Standard deviation is the yucky square root term. That turns out to be 0.04951. Now, just to remind you, you don't have to memorize that. It is right there on your cheat sheet. I find on test 3, people don't use their cheat sheet. They end up memorizing that wrong, and they never even look here. I give you the formula on your cheat sheet. Well, now I'm ready to get back to my question. P hat greater than 0.9. I'm going to turn the P hat into a Z. How do I get Z's? I subtract off the mean, divide by standard deviation. And here is another one that is off the chart. Greater than positive 9.49, there is nothing left. 0%. This is really similar to the other problem we did at the beginning of the video. Let's talk about part B. Part B says, I'm going to look at the next 10 students. And then they ask a question. So we got to check for normality. No, this is only 4.3. This is not normal. You cannot do part B. So this was not put on here as a trick. It was more just to make sure you understand that if we don't have normality, we don't have a question to do. Right, what's my last problem? Review day number 4. See, as soon as I start reading this, average life of a cat is 15 years, standard deviation 2. They gave me mean and standard deviation. This absolutely has to be an X or an X bar problem. Cannot be a proportion problem. Now I've got to read the parts carefully to know if it's X or if it's X bar. The mean is 15. Standard deviation is 4. Nope. Standard deviation is 2. Okay, part A, when sampling 30 cats. So that is my first clue that it's X bar. Then I'm going to keep reading. 18% of their means. That is the language. So you will know that it's an X bar problem. They give you a sample size and they use the word mean. Now this is a working backwards one. Again, similar to the one I probably did 30 minutes ago. 18% at least. There is your 18%. That is an area, but that's not the appropriate area because your chart wants the area to the left. And if you keep forgetting that that is not a z-score, feel free to make that area 4 decimal places to remind yourself you were looking in the body of the chart. I'm going to cheat and look at my answer key. Oh yes, you will end up finding 0.8212. That's the closest. That relates to a z-score of 0.92. See, it's positive. I was expecting positive, right? Equals, I don't know what X bar is. Oh, I forgot to do my little scratch work, didn't I? The mean is 15, obviously. What did I just forget to do? Because you might be going too fast, right? I'm not putting a 2 here because it's X bar. So, and I know I'm okay on normality because they gave me 30. X is normal. The mean is 15. Standard deviation is 2 divided by square root of 30. I forgot to do that part. That is 0.3651. That's the number you're putting into that formula. Use your algebra. You'll get 15.33 as the final answer. So again, since they gave me a sample size and they used the word mean, I know this is an X bar problem. I know I'm okay on normality because 30 is greater than or equal to 30. Which all feeds into the only difference between X and X bar problems is that standard deviation. The only difference is that guy right there. All right, let's finish up part B. Same problem. Part B says, assuming normality, what percent of cats? Okay, go very carefully on this one. It doesn't say what percent of the mean lifetime. It just says what percent of cats. Does not give me a sample size. And it needed to have stated normality because this is an X problem. They do not give you a sample size and they do not ask you a question about the mean. That's why I had to throw in there assume normality. So X is normal, 15, 2. Since this is an X problem, I'm back to using the 2 for the standard deviation. So this is just a stuck in between, going forwards X problem. We need to get our 2 different z-scores. So minus the mean over the standard deviation, minus the mean over the standard deviation. So while this is test 2 material, you're absolutely responsible for it for test 3. I had something extremely similar on test 2. Many people didn't know what to do when you were off the chart in the middle of a stuck in between. Same process. You're going to look him up minus look him up. Most people are fine with that guy. But remember we said you can't look up 4. But what is the biggest positive you can look up? 3.89. When you look up 3.89, you're going to see a 1. 1 minus 0.1056. That's the answer to part B. So hopefully I tried to pick out the problems that in general I'm usually asked about in the classroom. Please feel free to email me if you have other clarifications, questions, whatever. If you feel like it's something that the whole class might be confused on, please use the discussion board. And if I find there are some problems that everybody would like to see, I will make another video. So we're just going to kind of play that by ear, period. If you have an iPhone, FaceTime, I'll be happy to set up hours for that over the next few weeks, or we will figure out a way to get everybody the help that they need. Goodbye for now.